Hey guys, I'm the math professor, Kyle Martin. This is a channel to do your math homework fast and accurately, all right? Today we're doing a linear programming problem, or sometimes this is called an optimization problem, right? But either way, these problems look a little scary, all right? A little intimidating. This big paragraph that we have to kind of pull some inequalities out of. We're gonna have to graph something and find a bunch of points where a region that we make has its corners, all right? And we're gonna do something with that. So let's see if we can try this. We're gonna do this as quick as possible and as efficient as possible. Let's start by reading our question. It says a painter has exactly 32 units of yellow dye and 54 units of green dye. He plans to mix as many gallons as possible of color A and color B. Each gallon of color requires 4 units of yellow dye and 1 unit of green dye. Each gallon of color B requires 1 unit of yellow dye and 6 units of green dye. Find the maximum number of gallons possible. Okay, so I always tell my students to start by looking for what looks like a total number. Okay, if we can find our X, our Y, and then our totals, that's going to help us out a lot with this problem. Okay, so I'm looking and it says right off the bat that painter has exactly 32 units of yellow and 54 units of green. Those sounds like total numbers to me. So let's put those in our total column and see if they work. Our first one, this is 32, and our second one is going to be 54. All right, and what were those things? 32 was yellow dye. Put yellow over there, and the 54 was green. Put green right here. Okay, then we have to figure out what are the other numbers in here talking about. Well, if we just read through, I think we're able to figure it out. Let's see here. He plans to mix as many gallons as possible of color A, and then it says in color B. So each gallon of color A requires 4 units of yellow dye. All right, well, just right there, this is color A, and it's 4 units of yellow. So this 4, if I find color A, maybe we can call that X. I'll say color A in yellow, I can put a 4 right there. If this is color A, that means this one's going to be color B. Color B for the Y. This is our X, this is our Y, when we have an XY equation a little bit later. Okay, so that was right here, this is the 4. It says, and 1 unit of green dye. So again, this was color A and green, so color A, green, this is going to be a 1 for the 1 unit of green. Okay, same thing for color B. This time color B requires 1 unit of yellow. So color B, yellow, this would be 1. And what else do we have? That's 1, and then 6 units of green dye. Okay, so color B, green, would be 6. Okay, so we got our chart filled out. Now we have to decide what that means for our constraints or the inequalities here. Well, let's see. This one, if I have no more than 32 units of yellow to use, that means that I better take for color A, this is 4, color A is my X quantity, 4X plus 1Y, that's in my Y column, and then I can't go more than 32, so it has to be less than or equal to 32, okay? That means no more than 32. Same thing for the green, same idea here. 1x plus 6y is less than or equal to 54. So 1x, or I can just say x plus 6y is less than or equal to 54. And I can also say just y up there instead of 1y. Okay, what are some of my other constraints? Well, if I look at my very last sentence, it says, find the maximum number of gallons possible. Well, I know I want more than 0, right? So x has to be greater than 0, greater than or equal to 0, we'll say, and y has to be greater than or equal to 0. And when we graph that here in a second, I'll show you why those are important. Okay, first off though, let's see if we can graph all 4 of our inequalities. The 4x plus y is less than or equal to 32, the x plus 6y is less than or equal to 54, the x is greater than or equal to 0, and the y is greater than or equal to 0, okay? So let's see, if I number these, my biggest is 54, so maybe we can count by 5. So I'll do that real quick on my chart. All right, so I got my graph all marked up here. And again, we only need this first quadrant, right? It goes quadrant 1, 2, 3, 4, because we're dealing with all of our positive values. There's nothing that's going to end up negative here. All right, so then remember, you can graph an equation in standard form by using its intercepts. If you forgot how to do that, I'll link a video up here for you, okay? But let's see, if I take 32 and divide it by 4, my x value is going to be 8. So if I go on my x-axis here, out to 8, that'd be just right about there. We can draw a dot. And then same thing if I plug in 0 for the x, y becomes 32. So up on my y-axis, I need to go up to 32. Here's 30, here's 35, so 32 would be about there. Okay, and then do your best to connect these with a straight line. Okay, and then the same thing we can do for our other one. Again, x is going to be at 54 for this equation. So just before our 55. And let's see, 6 goes into 54 9 times for the y, just before the 10. And again, you can connect these with a straight line. Okay, so then for the other two inequalities, x is greater than or equal to 0 and y is greater than or equal to 0. I'm not going to do the entire thing here, but for x, remember if I go to x is 0, this is a vertical line. So I'm just going to do it right there because it's going to enclose this space. And same thing for y. Y is greater than or equal to 0. On y, if I go to 0, this is a horizontal line. Okay, and then I have this region right here that is bounded, right? The y is greater than 0, the x is greater than 0. And then this line, we want less than that. And this line, we want less than that. Okay, so we're stuck kind of in that region for our constraints. Okay, and remember, at the corners of those regions are going to be our possible solutions for our optimization, our maximums and minimums. And we want, in this case, the maximum number of gallons. All right, so we have to say what these corners are. And I think 3 of them are easy to find, and one of them is going to be a little tricky. So let's find the easy ones first. This is the point 0, 0. Okay, that's going to be one choice. I'll put those maybe over here, 0, 0. Let's see, this is the point 0. Remember, this was 8, I think. Is that what that one was? Yeah, 8, 0, 8. This is the point, or was that 9? I think this was a 9, sorry, 0, 9. This is where it helps to have graph paper. You can make yours a little bit more precise than I am. 0, 9, this one's going to be 9, or let's see, this one's the 8, right? 8, 0. 8, 0. And then the one that's hard to find is this one, that corner right there. Now, if you have graph paper, you might be able to see exactly where that crosses on the graph. But if you don't, you can take those two lines, which happens to be our two kind of slanted ones, and just do a system of equations and solve for x and y there. All right, so if I do that in this one, let me do this really quick for you. This, let's see, I'm going to multiply the bottom one times -4, I think, and that way my x's can cancel. Let's see what happens when I do that. Okay, after solving for this system of equations, again, what I did is I multiplied this bottom, and I made equations, right? We don't really care at this point that they're inequalities. We're just trying to find the point where those cross so I can make them equations now. But anyway, I multiplied that bottom one times 4, and that gave me this, right? And when I do the addition, the x's cancel, which is good, which gives me -23y equals -184. Divide to get y equals 8. And then I plug that back in. I think I used my bottom equation here, x plus 6 times y, which now I know y is 8. So 6 times 8 is 48. And then move that over and get x equals 6. So my other point that I need is going to be this one, which is the point 6, 8. All right, 6, 8. Now that I have those 4 points, the 4 points of my enclosed region, I can get rid of this. And I need to come up with my objective quantity, okay? And what that means is, what am I trying to figure out here? And I need to figure out, it says find the maximum number of gallons possible. It says each gallon of color A, each gallon of color B, each one's going to be a gallon. Really all I need to do is, since A is talking about X and B is talking about Y, is I need to add those together. X plus Y equals, and that's going to be, however many I can make is going to be the answer, whatever one gives me the maximum, right? In this case, let's see, 0 plus 0 is going to be nothing, right? That's going to give me no gallons. 0 plus 9, if I do 0 for X, 0 plus 9 is 9 gallons. So this one was 0, this one's 9. 8 plus 0, 8 plus 0 is 8. So obviously the biggest one it's going to be is 6 plus 8. 6 plus 8 is going to yield 14 gallons of those colors. And so therefore, we can optimize this by saying 6, 8, or in our case, 6 gallons of color A and 8 gallons of color B. Okay, so the answer to this linear programming problem, 6 gallons of color A, 8 gallons of color B to create the most gallons possible. All right guys, so I know that was a pretty tough problem, but if this helped you out, please like this video down below and subscribe to my channel if you're not already subscribed. We'll see you in the next one.